I thought I would do a few of these problems from the lesson on permutations and combinations, just to maybe help provide a little more clarity to what we talked about in class today. So I've chosen, as you can see there, 11 and 14. So let's take a look at number 11. So we have the student who wants to take 6 different classes next year. Each class is offered each period. How many different schedules could she have? So if you think about it, a class, there cannot be 2 classes offered during the same class period. So we have to have a first period and then a second period and then a third period. So definitely we're talking about an order here. Order is really all we're talking about. How many different ways can we arrange these 6 different classes? And so the directions are, we have to identify whether we have a permutation or a combination. And you can just put P or C. This is definitely a permutation. And since we're arranging all 6 classes, it's not part of the 6 being arranged at a time. When you're arranging all of the items in the set, then it's just a matter of doing 6 factorial in your calculator. And the answer here would be 720. How many different schedules? We could say 720 different schedules. All right, number 14, a band is choosing 3 new backup singers from a group of 18 who try out. How many ways can they choose? It's not always true because I've seen the word choose come up in permutation problems, but choosing is the idea behind combinations. And so some people actually think of the big C that really stands for combination. They think of the word choose. So in this case, we have 18 total in our group who try out, but we're only choosing 3. So for this one, we're going to go to our calculator. And again, this is not a permutation because we're not asked to arrange any people. It's just choosing how many smaller groups can we choose out of a bigger group of 18. So 18, PRB, then we go to NCR, and then we type in 3, and the answer is 816. Choose 816 3-group backup singers. All right, and then the next one. We have a department store has 9 employees available to cover 4 different sections of the store. So another way, this is how many ways can the employees be assigned. That's one of the key words to indicate permutations. But if you think about it, another way of, you can also reason through permutations is these employees cannot cover more than 1 spot at a time. And that's also true with permutations in general. You've got slots that have to be occupied by just 1 person, obviously. So we got 4 different sections of the store, and we've got 9 different employees available to cover those. And so we're going to assign these employees 1 employee per section. So this is going to be a permutation. And so 9P4 in our calculator, 9 PRB NPR 4, and that's 3,024. How many different ways can they be assigned? And you can just say 3,024 ways that those 9 employees could be assigned to these 4 different sections. 18, Jack has a reading list of 12 books. How many ways can he select 9 books from the list to check out of the library? So we're not told anything that these books have to be chosen or selected in any particular order. It's just how many 9 book selections can be made out of a total of 12. Order is irrelevant. So this is going to be a combination. and so it's 12C9, and we'll go back to our calculator. 12 PRB NCR 9, and that's 220 different, let me say, selections. Okay, and then we get to this challenge problem, and so Abby is registering at a website and must select a 6-character password. The password can contain either letters or digits. Okay, so letter A is how many passwords are possible if characters can be repeated. All right, so we'll take this in 2 different sections. So we'll say repeats, no repeats. 2 different answers really for part A. All right, so let's just kind of lay it out here. It's a 6-character password. And we have, since it can be letters or numbers, letters or digits, well, there's 26 letters, and there's really 10 digits because the numbers 0 through 9. That's 10 digits, 26 letters. If they can be repeated, that means I've got 36 options for this first character. And since they can be repeated, that means I've got 36 options for every one of these. So it's just a matter, this is an example of the fundamental counting principle. It would be 36 to the 6th power. And that is a pretty big number, so let me write that down for you. All right, so we're looking at, if I wrote that down correctly, 2,176,782,336. Okay, well, what if they cannot be repeated? It's still 6 characters, and we've got still letters or numbers that can be used, but if they can't be repeated, I've got 36 choices for this first slot, but then that means I only have 35 available for this. They can't be repeated. So I've used 2 characters here. That means I've got 34 remaining for this position, meaning I got 33 remaining for this, 32 for this, and then finally 31 for this. And so the fundamental counting principle would say I just multiply all of those numbers together. And if you multiply those together, you get 1402, 410, 240, 1,402,410,240. So those are the 2 different answers that we got for letter A. All right, now letter B, how many passwords are possible if all characters are letters that can be repeated? Okay, so it's still a 6-digit, but it's just letters that can be repeated, so that means 26 really are possible for every one of these slots. So again, fundamental counting principle says we just multiply all those together. 26 to the 6th power. 308915776. 308,915,776. All right. If the password must contain exactly 1 digit. Okay. So that means one possibility, all right, so we got these 6 characters, 1 digit, so let's pretend like, for example, that digit is the first character. So we got 10 choices, and then all the others have to be letters. All right. And then from part B, this is just a follow-up of part B, we're going to assume that the letters can still be repeated. So that's one option. Another option would be I could make the digit the second character. So that's a possibility. And then I could make the digit the third character. Just okay, that's another possibility. So you can see we're just working our way through this pattern until we let this digit basically start in the first position until we end up at the last position. So there's really 6 different versions of this, moving the digit from first all the way to the end. So if you do this times 6, that's going to get your answer. So let's see what that is. 26 to the 5th power times 10, and then that number times 6, because there's 6 different iterations of that. And let's see, that is 712,882,560. So then the final question there is, which type of password is more secure? Well, obviously the version that has the 1 digit mixed in would give you, this is a 1 in $712 million chance to guess correctly, and this is 1 in 308 million. So we would say the password with 1 digit. So guessing at random with that is a 1 in 712,882,560 likelihood versus without the digit. Still a great long shot, but it's 1 in 308,915,776. All right, so those are some of the homework problems from this assignment. So I hope that helps maybe clear up any questions you had from our lesson in class. If you do have any questions, feel free to let me know.